Here I go. Oh yeah, last time we were here we did equations of tangent lines. I'll talk more about that today. Anyways, problem 12 says let's try to compute three things, okay? So my function f of x is x plus 2 over x squared minus x minus 6. And so I'm going to start by putting that in the calculator. Okay? I think that's going to help. So I'm going to go ahead and graph that. I have, oh, look at that. A lot of trigonometry going on in the other class. Wow. Those scientific people. Let's get that off there. Okay. So we're going to go ahead and we're going to try, let's see, x plus 2. Use parentheses for both the numerator and denominator here. Divided by, let's see, x squared minus x minus 6. Okay. There's my function. I want to graph it. Ooh, yeah, look at that. Look, looks almost like a heartbeat with the... Well, anyways, let's try changing the window to maybe what you're going to see. I had this thing all set up for my trig class. Zoom standard, does yours look something like this? Mm-hmm. Okay. Now, the calculator screwed up. I have an older one here. This is a TI 83 Plus. Some of you have an 84 Silver. There's some nice calculators out there that do maybe a better job than this one. Okay. But what it's trying to show me here is what? The asymptote. The asymptote, yeah. And so, I mean, one thing you might ask is, where is the asymptote? Right? And I can do this. I can factor that denominator. That denominator can be factored how? X minus 3 times x plus 2. Right? And that kind of gives you a clue as to where the asymptote might be. When x equals 3, the numerator would be 5 and the denominator would be 0. So that's a good key that we're going to have an asymptote at that point. If you make the denominator 0 but you don't make the numerator 0, you're going to have an asymptote. Okay? So as I look at this problem, there's three parts. There's part A, the limit as x approaches 3 from the positive side of this f of x. Part B says, oh, no, wait a minute. Part A is the negative side. Sorry about that. Part A says, what's the limit as we approach x from the negative side? Rewrite. Okay. Limit x approaches 3 from the negative side of f of x. B, we want the limit as x approaches 3 from the positive side of f of x. And then part C says, okay, guys, what can you tell me about the limit as x approaches 3 of f of x? Okay. So we'll see what we come up with here. Now, as I look at the picture, I mean, that says a lot right there. What you can do is you can put in something close to 3, and they suggest it, right? So for part A, if for example, I hit second calculate a value like, let's do 2.99, I'm approaching from the negative side, right? And what's happening? It's really becoming very positive or very negative?
Very negative.
Very negative. It's going down a lot, right? And so what I would say, there's a nice symbol we use to say that. We say that this limit as x approaches 3 from the negative side, this is negative infinity. Okay? Now, that's kind of weird. Infinity is not a number. What this really means is the function decreases without bound. This thing just keeps getting smaller and smaller, and it's not bounded by anything. It can get as low as you want. If you did 2.99999, enough nines, you'd get as low as you want. Okay? But what about this one, part B? Well, you can actually see from the picture again, if I put in something just to the right of 3, I'm really big. And so I would say that this one is positive infinity. What do you think that really means? Well, you're probably right. Increases without bound. Decreases without bound or increases without bound. That's what it really means. Does that make sense to you guys? But again, there's a difference when I'm coming from the left side in this problem or when I'm coming from the right side in this problem. And so now if I try to compute the limit, I'm going to say it does not exist. Because you have to be going to the same value from the right as from the left for me to say the limit exists. Okay? That's different from number 9, and I think that's what got people. See, let me graph number 9 for you. Number 9, the function was y equals 1 divided by, here, let me clear it out. What was it? 1 divided by what?
X minus 1 squared.
Okay. So if I have x minus 1 in parentheses, and if I square that, and let me show you that graph. Okay? You have this picture. There's still an asymptote where? For number 9. Well, yeah, there is an asymptote on the x-axis. You are right. If I say y equals 1 over x minus 1 squared, I'll just do it up here. The picture is, well, yeah, we have this on the x-axis because all of my values are going to be positive. That's called a horizontal asymptote, right? But we also have a vertical asymptote. Where's the vertical asymptote? X equals 1, okay? And so now what the question asked is, hey, what happens when you come in from the left? Well, you go to positive infinity. What happens when you come in from the right? You go to positive infinity. So for number 9, they did say that the limit as x approaches 1 is positive infinity. They're telling you that I don't care which side you come from, the function grows without bound. That's different from what happens in 12. Go ahead, Matt.
So in number 12,
Yeah.
Well, going on from that, in number 18, it has the exact same numbers.
Right.
Asking you to get the limit algebraically. So how would you figure out that the limit doesn't exist
Algebraically?
Yeah.
Okay. So let me do that. In 18, we take the limit as x approaches 3. And again, remember I had factored it. X minus 3 times x plus 2. That's using algebra. Well, it turns out that limits, to compute a limit, you can cancel. And that won't change the limit. To show it to you, all right, let me show you. Oh, no, I deleted it. Well, basically, what happens is if I cancel, then this is the limit as x approaches 3 of 1 over x minus 3, right? You can see we have trouble, right? Because if I put in a number larger than 3, this is going to be positive. If I put in a number smaller than 3, what's going to happen? It's going to be negative. You see that? So you're going to get that behavior algebraically. It does not exist, okay?
Would you also know that from when you put in 3, then it's going to be undefined?
Right. It would be some non-zero number over 0, right? Whereas, what if I asked you guys the limit as x approaches negative 2? Well, here you'd get 0 over 0, and you'd say, oh, indeterminate. So then you'd cancel. Could you put a negative 2 in here? Sure. You get negative 1/5. So you could take the limit as x approaches negative 2. But you can't take the limit as x approaches 3. That one does not exist. Right? I get 1 over 0. That does not exist. That's an asymptote. You guys follow? There was one other one from this homework, 36. I wanted to mention something about. Oh, it says use the graph to figure out the limit. And so 36, here, let me just show it. It's asking me, I better zoom in a little, you won't see that. Well, you guys have your books. Here. It says limit as x approaches 2 from the negative side. That means from the left. And we're supposed to look at the picture on the next page, so let's look at that. So as x approaches 2 from the negative side, well, you could see what's happening, right? I would say the answer is positive infinity. That means it's growing without bounds. But the actual limit doesn't exist because it's not the same on both sides. And then some of you asked about the, I think it was problem 42. They asked for the, what happens as x goes to negative infinity? I don't really know. It looks to me like there's an asymptote. And if I had to guess where the asymptote is, I would guess it's the axis. Because I see an asymptote here and I see an asymptote there. I could see that we're getting below 1. Some of you guys put 1. No. I noticed that when I put in negative 3, I'm at 1. Some of you guys said it's a half. Okay, maybe you're right. I don't know because I don't know what the function is, right? They never really told me. But there definitely is some kind of asymptote. You can see it flattening out. You guys with me?
Can you explain that again?
I can see that it's flattening out. I can see from the picture that it's never going to get below the x-axis.
Mm-hmm.
So I'm thinking that y equals 0, the x-axis, is an asymptote. And so when they ask me in problem 42, hey, what is this limit? I'd say 0. I think that...
But is it the asymptote at -1? So wouldn't it be, wouldn't it stop at -1?
But you got to look at what it's asking here.
Mhm.
When we talk about limit as x approaches either infinity or negative infinity, those are always horizontal asymptotes.
Oh.
These other problems had to do with some of the vertical asymptotes. But problems 41 and 42 have to do with the horizontal asymptotes. Because what's that mean, infinity or negative infinity? It means on the graph, we're going off the map either this way or that way. That's talking about horizontal end behavior, they call it.
Oh, so you're looking at it as it goes.
As we go off the map to the right or to the left, positive infinity or negative infinity, what's happening? Well, as we go to negative infinity, I'd say this thing's never going to get below 0.
Okay.
Make sense?
Okay.
Okay. All right, that was a lot of 2.2 stuff. Do you guys have questions from 2.3 homework? And give me the name one more time.
Gina.
Gina, go ahead.